Hey Algebra 1 students, I hope you're having a good night. I'm going to go through this little PowerPoint for you on some basic properties that many of them I think will be review for you. Section 1.3 is full of these properties and they're very important. Like I said, I think many of them you know already. So I'm going to scooch through these, talk about them, try to explain them to you. At the end of this PowerPoint, there's a couple examples that I think will help you do the few problems that I want you to do for homework, which I think I only assigned maybe 10. So why don't we get started? The commutative property, you should know. You've had this one before. The commutative property is when you multiply x times y, and it's the same thing as y times x. That's for multiplication, and for addition, it works the same way. X plus y equals y plus x. Basically, it's saying you can swap the numbers and you get the same result, and you should know that already. The commutative property, oh, here's a little, by the way, I had my Algebra 2 honor students put together some of these slides in class, so they put some visuals in there. Commutativity does not apply to division and subtraction, so you cannot swap numbers when you're dividing or when you're subtracting. 5 minus 3 is not the same as 3 minus 5. The associative property, it refers to grouping. Basically, this works for addition and multiplication of real numbers. As long as x and y and z are all real numbers, if you group the first two, and then group x and z, you will get the same result. Same thing with multiplication. It works for addition and multiplication. You can regroup them. The distributive property, it's when you multiply the outside number with each number inside the parentheses. And you have done this before too. In this example, x times the quantity y plus z is the same as x times y plus x times z. You basically distribute that number on the outside through all of the terms in the parentheses. The additive identity is basically what it's saying is for any number, when you add 0 to it, you don't change it. Okay, you know that. When you add 0 to a, whether you do it 0 plus a or a plus 0, you're going to get a. And I have an example there for you. The additive inverse is a number and its opposite. When they're added together, they are inverses of each other. Basically, a number and its negative. So if you have 3 plus a negative 3, you're going to get 0. 0 happens to be the additive identity. Okay? When you have an additive inverse, your result is your identity, okay, which is 0 for addition. If you have 17 plus a negative 17, you're going to get 0. The multiplicative identity, same concept, except when you multiply any number by 1, you don't change it. In addition, when you add something by 0, you don't change it. It keeps its identity. It's where the word comes from. So a times 1 equals 1 times a, which is just a. Okay, so no matter what number you multiply by 1, you do not change it. The multiplicative inverse, very similar to the additive inverse. For every number a over b, where a and b are not equal to 0, there is exactly one number b over a, such that the product of a over b and b over a is 1. Basically, they're saying if you multiply something by its reciprocal, you get 1. That's the multiplicative inverse. If you've got 5 over 6 and you multiply it by 6 over 5, you're going to get 1. Okay, no matter how you slice it, if you multiply a number by its reciprocal, you're going to get 1, and 1 is the multiplicative identity. The multiplicative property of 0 basically is saying if you multiply 0 times any number, you're going to get 0, no matter what. So the example I have there, 6 times 0 equals 0. It could be 5,642 times 0. You're getting 0, okay? That's what that property says. Now these are some things that are just, maybe they're just obvious to you, but they actually have names, and they are considered properties used to prove things in algebra. Okay, when x is a real number, x equals x. It's like looking at itself in the mirror. That's why it's called reflexive. X equals itself. A number equals itself. Pretty straightforward. Symmetry. X equals y, then y equals x. Okay, that is symmetry. Transitivity for equality is if x equals y and y equals z, then x equals z. You can see here, x equals y equals z, then x will equal z. And the same things works for inequalities, but we aren't going to be doing much with that quite yet. So concentrate on the equality one first for this section. Substitution. A quantity may be substituted for its equal in any expression, and you know this as well. Plug and chug. You've used this throughout pre-algebra. If A is the same as B, then you can replace B wherever you see A in an expression. So here I have n. If n is 5, then 4 plus n is the same as 4 plus, oops, there's my typo. That should be 5. Sorry about that. I will have to fix that on the PowerPoint. So n equals 5, then 4 plus 5 equals 4 plus 5. Oh, I'm so mad I did that. Okay, this is going to be like a little, I'll know you watch this if you notice my screw up. I may have to put this on a quiz or something. Okay, almost done. Here's an example. Here is some an expression that we're simplifying. Okay, notice right here, 4 minus 3. The first thing you do is you do that subtraction. It's order of operations, and it's 1. 4 minus 3 is 1. That's substitution. We substituted 1 in for 4 minus 3 because they are the same thing. What happens from here to here? Multiplicative identity. When you multiply 1 by 7, you get 7. That's the multiplicative identity. Here, in this section right here, when you multiply 5 times 1 over 5, you get 1. That's the multiplicative inverse we just talked about. And then these last two sections, when you do 7 minus 1, you get 6. 7 minus 1 is 6. You can replace 6 with 7 minus 1 because they are equal to this substitution. 6 plus 1 is 7. That's substitution as well. So every step that you do when you're simplifying an equation, there is a property that is allowing you, that says, okay, yes, you can do that, okay? And there's actual names for them. Here's a couple more examples. This is a little bit more like what you're going to do for your homework. Find the value of x. Then they name the property used. You are going to do problems like this in your homework. Here we go. 10 equals 10 plus x. What does x have to be? Come on, you know this. Come on, what does x have to be? 0. Now, which one of the properties says that you can do that? That when you add 0 to something, you do not change it. Additive identity. X is 0. That's the additive identity property. 6 plus 9 equals 9 plus x. What is x? Come on, you know this. Come on. I know. You should be shouting it at the screen right now. It is 6. Okay? X is 6. The commutative property tells us that's true. Okay? It doesn't matter what order you add things in. Alright, now this whole presentation I went through very quickly. So I will have a copy of this presentation with my corrected slide. I can't believe I made that mess, that little screw up there. Along with this video, so that you can actually go through the presentation at a slower pace if you'd like and read through it to help organize your thoughts and make sure you understand how all of these properties work. They are also in your book, so you can read through some of the problems in your textbook, online textbook, and hopefully all of this will make sense to you. Do the best you can on these problems. We will discuss them in class next time. So good luck with that, and please feel free to watch this again if you need a little bit more reinforcement. Have a great night.